Hello everyone, it's Nono here and we're going to take a look at how to draw shapes with opencv. So I'm here at a directory and I'm simply going to create a draw.py file. So we can open our Visual Studio Code and we have that file here to edit. The first thing that we would do here is that we would import opencv, right? So this is actually import opencv library, but this is leaked to fail right now because if I run Python or Python 3 with this script, opencv doesn't really exist. So how do we install it? First, I'm going to create a new Conda environment for opencv, and I'm going to make sure that we install Python 3.8 and ipykernel to create our own Python environment. Once the environment is resolved, we can proceed. And Conda is going to create a custom environment for us to develop there. opencv is not installed, we still have to install it with pip, but once the environment is created, we can run conda activate cv2, and then as you can see in here, this between parentheses that marks that we're inside of this environment. So I can do now pip install opencv-python, and pip is collecting our packages and installing opencv. Now we can run our script again. So I like to always do which Python to see that the version of Python that we're using is the version that Anaconda created for us inside of the CV environment, which will have the opencv dependency. So now we can run python draw.py, and now we see that there are no errors. We could even print cv2 here, and we'll see that the package gets printed. All right, so let's get started from an empty image. We'll import it here, import numpy as mp. And now we're gonna create a black image. So you're gonna create mp0, and the image is gonna be 256 by 256 and RGB, and it's going to be filled with zeros, right? uint8. And now we're gonna draw a diagonal red line with thickness of 3 pixels. CV line IMG 00 to 28 to 128. So this is from the top left corner to the center of the image. And now RGB, I believe instead of RGB, opencv does BGR. So to do red, we probably have to do 00 to 55. And then specify the thickness, which is 3. That's it. So let's see if this runs. So if we execute our Python draw, so CV is not defined. We gotta put it here, no attribute live. And now that this is working, we could save our image. So we have to define a save path. And my example is that I'm going to put a test PNG on the desktop, and I'm going to use cv.imwrite for image, providing the save path and the image that we're creating here. So when we now run our draw.py script, we can see here on the desktop, we have a new file. So we can open that image and we can see this is a black image with 256 side and width and height, and the line goes from the top left corner to the center of the image as we promised. We can now change our script. So for example, we could change the color here and maybe save again. So just rerun this, and now the color is orange, right? Maybe let's try to open our image here and rerun this. So this image actually can update. Okay, so what are we gonna do now? So we could say we're gonna draw more lines. So for example, we can now draw another line that goes to the right and re-execute once again. So we can do as many lines as we want. Of course, we can not only draw lines, so we're gonna put here, maybe let's just put our line only at the top, so maybe from 2020 to 20 to 5020, right? So we leave that there. and then we get our line in there. So now we're going to draw a rectangle that is going to just require cv.rectangle, and then our image, and then the coordinates where we want this rectangle to be. So we're going to go also for 20, but now 40, then maybe 40, 40, then 40, 60, and then 20, 60. Let's try to see what happens with this. So we go to our terminal, run again, and it takes 4 arguments. All right, so we actually passed more arguments than we needed. We just need to pass 3 points, or 2 points actually. So just the 2 opposite corners. So this one and this one. So we're just gonna pass these 2 and then a color here. So we're gonna make it blue in this case, and the thickness is now gonna be, let's do 1, right? So we redraw. Okay, that's a bit small, it's hard to see. So maybe let's put some more color to it. But yeah, you can see the rectangle there. So maybe let's just make it a bit bigger. Cool, so we have our rectangle there. We can maybe draw another one with an offset and do that. All right, so we have our rectangles there. Now we're going to quickly draw a circle. So CV circle. We just need to, again, pass the image. We pass the center point, which now is going to be, let's say, 280. The radius, which is going to be 40. And again, the color, which is, in this case, we're going to try to make it red. And the thickness, -1, all right, which is infill. And we're going to make here 1 for that outline, right? So we could, the resolution here is not great because the image that we're doing is super small, but maybe we can have a scale factor to give it a bit more resolution. So define scale, and imagine that we always have a 100 by 100 canvas. For this, we would say 100 by this. So let's do 0.4. So by 0.4, just to keep the same image. So 8, 50 by 0.4. And what I'm going to do, I'm just going to replace all the numbers with multiplying by 0.4 so they appear the same to a 100 by 100 canvas. All right, so let's see what happens now. So we're going to maybe just put this here. Okay, thickness needs to be an integer, so maybe let's just leave it like this. And now our image is small, but it respects the similar proportions of what we had before. So now we multiply everything by our scale. This is gonna make our everything a bit messy, but it's okay. So let's use the terminal in Visual Studio so we can just run from here. All right, so what you can see now is that this has a lot greater definition. We haven't scaled the thicknesses, which we're gonna do right now. All right, and I'm gonna create this thickness variable here just to make sure we can control that, and that's invariant for now across our drawing. So now we have this thing, and we can ask right now the canvas is 100, and now we could get, this is a 1000 pixel image. We could get a 2000 pixel image if we scale by 20. And we take a look at here, right? So the quality of the drawing is a lot better. So we can append here the add to see it at the original resolution. So you still see there's some edges that are a bit rough. There is no anti-alias here, and that's okay. We didn't really look for that. We can lastly take a look here at how to draw a polygon. So we could say we have an array of points, which we just put here an array and say, okay, we have maybe from 20, the start point is going to be 2070, and then we get maybe 25 and 75, then we go to 50, 80, then maybe 33, and so we have 4 points now. Let's add one more. So we'll go to 30 and 90, and we say that this is going to be an array of 32 integers, and then we reshape into -1, 1, 2. Now we call CV polylines with the same image. We pass an array of points, true, and then the color here, which is going to be, is in cyan. We once more draw. We open this image, and we have a really little tiny polygon there because we didn't really scale it. So we need to scale all the points. I'm not sure if we might be able to just multiply this here. We can, yeah. So when you have an MP array, you can simply multiply here and the entire contents multiply. So you can see this here. And yeah, that's pretty cool. We could specify here maybe a different thickness. Yep. Or maybe even put -1 so it gets filled. Oh, no, it doesn't let us do it. All right, so we'll just put the same thickness and everything. We call it, and that's our polygon. All right, and one last thing, as we commented before, you can see here, if I render this image, that there are some jagged edges, right? They're rough. This is like a staircase, and we only have yellow and black. If we open this in a program like Photoshop, you have an image that we see the same when we zoom in. And if we export for web using the PNG format, you're going to see that we only have a color palette of the 5 colors that we're using: black, blue, red, yellow, and green. We can avoid having those jagged edges. So I'm going to put here, instead of test JPEG, I'm going to put test Anti-aliased to save a different image. And we're going to add, just for example, to that circle, the CV line AA option. So this option is going to force an anti-aliasing rendering on that circle. So when we run this thing, we're going to see that we save a different image, open in Photoshop as well. And then when we zoom into here, you can see that there are those jagged edges. If we put this at original resolution, they're not a staircase like in here. So let's try with this yellow one. We copy this attribute to the polylines drawing, then we run it, and we have to reopen that image. And now look what happens. We don't have that full staircase anymore. And if you go from afar, you don't really tell there is some imperfection in there. But what this does is that if we export again for web, trying to go with PNG again, look at this. Now we have a bunch of interpolation colors that go from black to red and from black to yellow that are going to add a lot of noise to our image. Our perception is that the image is a lot clearer, but if we want to use this for something that is important for us to have colored pixels with specific values, this is a bit of a mess, right? We have this color here and this color here, which is 20200, whereas the red that we specified was 25500. And that might be a problem or not, but that definitely adds a lot of smoothness to your drawing. So if we put a thickness of 50, draw again, we get those shapes here, we update. Now that looks really clean. And you don't really tell that this is a circle drawn like that. If I come closer, that the borders are perfectly anti-aliased. That's not happening here. You see how this is still jagged. So let's add anti-alias to our entire drawing. So everything that we're painting here, to these three, the line operation, the two rectangle operations, we redraw. We once again load this image in Photoshop and then update. And then we see how this instantaneously is smoothed out. And everything in our drawing is now a lot nicer. You can still see some imperfections if you go closer, but if you put it at a real resolution, we have a perfect drawing. And this concludes the tutorial or the overview on how to use opencv, how to create your own custom Conda environment to draw, and how you can do different shapes, lines, rectangles, circles, or polylines, and how to use anti-alias to make it look nicer. And also we saw the trade-offs of what it implies to make something anti-aliased and how we get to introduce many more colors that were not in our original drawing image into the color palette. Thanks so much for watching. This was Nono Martinez Alonso. In case you haven't seen other videos, I have a live stream in machine learning, also videos on web development, a podcast called Getting Simple that talks to different creators. We have long form conversations in which we discuss creativity and many other things. So yeah, without further ado, I will like to thank you for watching, and I'll hopefully see you next time. Bye.